A lot of us think of math as, well, just a boring subject we had to get through in school, right? But it's actually a hidden language that describes pretty much everything around us. From the shape of a skyscraper to the interest on your savings, math is like this invisible blueprint. In this explainer, we're going to decode a little bit of that blueprint, and we're going to start with a pretty interesting question.
So, what could a Ferris wheel possibly have in common with the ocean tides? It seriously sounds like a riddle, doesn't it? But the answer, well, it's this really beautiful mathematical pattern, and it's just the first of many we're going to uncover today. So what we're going to do today is take a little journey. We'll see how just a few key mathematical ideas can help us measure the world around us, understand its natural cycles, track patterns of growth and decay, and, yep, even plan our financial futures. We're going to find the math that's hiding in plain sight. All right, first stop on our tour, space and distance. Specifically, how we can use the elegant logic of geometry to measure things that are way out of our physical reach. And get this, it's a trick that people have been using for centuries, and it's way simpler than you might think. Okay, so picture this. You're standing on the bank of a really wide river. You absolutely need to know how far it is to the other side, but you don't have a boat, there's no bridge, no way to stretch a tape measure across. So what do? Well, you don't need a boat, you just need a triangle.
So here's the super clever solution that surveyors use all the time. First thing you do is measure a perfectly straight line along your side of the river. Let's call it 300 meters long. That's your baseline. Then, from each end of that line, you just measure the angle to a landmark way over on the other side, like a big tree. And just like that, with those two angles and that one side length, you have everything you need to map out an invisible triangle. And then, with a little bit of high school trig, specifically the sine law, bam! You can calculate the exact height of that triangle, which happens to be the width of the river. And in our case, that works out to exactly 125 meters. You've measured the unmeasurable without ever getting your feet wet. What a great aha moment, right?
And this is the really cool part. This trick isn't just for rivers. This is the exact same fundamental math that lets a pilot flying at 2,400 meters figure out the distance between two forest fires on the ground. Or it's how you can find out the height of a skyscraper without ever leaving the sidewalk. It's incredibly versatile.
Okay, so we've tackled things that just sit there, right? But what about stuff that moves, that repeats? Our world is absolutely full of rhythms, from the really small to the absolutely massive. And that brings us to our next stop, the mathematics that describes these beautiful, predictable cycles.
Just think about it for a second. The swing of a pendulum, the rise and fall of the tide, the steady spin of a Ferris wheel. These aren't just random things happening. They follow this predictable, almost musical, wave-like pattern. And wherever you find a pattern, you can bet there's math to describe it. And this right here, this is what brings us back to that first question about the Ferris wheel in the ocean. Whether we're talking about a theme park ride or the actual sea, we use the exact same words to describe them. The highest point? That's the maximum. The time it takes for one full rotation or cycle? That's the period. And that average level, right in the middle, that's the axis of the curve. Totally different things, but they speak the exact same mathematical language. Now, the secret weapon that makes all this possible is something called a sinusoidal function. It's this incredibly powerful tool, an equation that lets us perfectly graph these repeating wave-like rhythms. It's the key to modeling and predicting pretty much any cyclical pattern you can find. So, and this is crucial, once you have the function, you literally have the power to predict the future. For example, using one of these functions, we can model the tides in a harbor. We can know that high tide is going to hit a maximum of 4.5 meters, and low tide will drop all the way to 1.5 meters. We can even calculate the exact depth of the water at 9 a.m., or any other time we want. It basically turns the wild, chaotic ocean into something as predictable as a clock. It's amazing. All right. So we've looked at still objects, and we've looked at things that repeat in a cycle. But what about patterns where things just grow or shrink over time? This brings us to our third stop, the incredibly powerful mathematics of compounding growth. Now this is a completely different beast. This isn't a wave that goes up and down. Nope, this is a curve that sweeps relentlessly upwards or downwards. It describes things that don't just add up, they multiply. We're talking about the math of exponential change. And to really wrap our heads around this, let's look at a fantastic real-world story. It's about a Wayne Gretzky rookie hockey card. Way back in the year 2000, a guy named Simon spots it on eBay and nabs it for what sounds like a pretty decent price, $500. So, Simon figured the card would go up in value by about 7% a year. Now, 7% doesn't sound like a lot, does it? But this is where the magic of compounding kicks in. By 2010, it was already worth almost $1,000. By 2020, that initial $500 investment had almost quadrupled. That steep, upward curve, that is the signature of exponential growth.
But here's the thing, this powerful pattern isn't just about growth, it works in reverse too. It can also model what we call exponential decay. Imagine a scuba diver going deeper and deeper into the ocean. The light from the surface doesn't just get a little dimmer with each meter, it fades by a percentage, which means it disappears faster and faster the deeper they go. It's the same math, just heading in the other direction. And all of this, it brings us to our final stop on this journey, and it's one that's super relevant to pretty much all of us. We're going to talk about the mathematics of money. Because, let's face it, anytime you're dealing with a loan, an investment, or even just a savings account, you are smack in the middle of exponential growth. And understanding this math isn't just some academic exercise. It's absolutely essential for making smart financial decisions.
Okay, let's take a loan, for example. Say you borrow 10 grand. Over 3 years, you make your steady monthly payments. But when it's all said and done, you look at the numbers and realize you've paid back over $12,000. That extra 2 grand is the cost of borrowing. It's the interest that's been calculated using these exact same principles, making that hidden cost crystal clear.
But it's not all bad news. The great thing is this same powerful math can work for you, not just against you. This is the tool that lets you figure out exactly how much you need to set aside each month to hit a savings goal of, say, $200,000 in 15 years. It can turn a huge, scary number into a totally manageable, step-by-step plan.
And there you have it. That was our whole journey. We started with some basic trigonometry to measure a river we couldn't even cross. Then we used sinusoidal functions to predict the rhythm of the ocean tides. And finally, we used exponential math to see how an investment can grow and how we can plan for our own future. They feel like completely separate worlds, but they are all connected by the same elegant, powerful language of math. So, what's the big takeaway here? The world is just full of these hidden numbers and secret patterns. They're in nature, they're in the technology we use every day, they're in our routines. The real question is, now that you know a little bit about what to look for, what patterns will you start to see?